Okay, we will be starting now. Hello everyone, my name is Jean-Baptiste Fleury. I'm a pre-sales engineer at AVSimulation. The topic of the web event of today will be human factors in the context of ADAS design and autonomous driving using Scanner Studio. And we will be focusing on eye tracking and different use cases related to human factors in the automotive industry. So just a quick recap about Scanner Studio. So Scanner is a driving simulator as well as a vehicle testing software. I know a lot of attendees today are using Scanner daily, but this is just a quick recaps for people who might not know Scanner. So Scanner offers a wide variety of tools and basically allows engineers to design all the aspects of a vehicle, being headlights, sensors, ADAS systems, but vehicle dynamics too. And this is really the strength of Scanner, is that you can use just one software to design the entire aspects of your vehicle, from the design part all the way to validation of your vehicle. And so, of course, the parts that we'll be focusing on today will be the driver part and the human factors. But yeah, Scanner is a software to design complex scenarios in a road network situation. But it's also an authoring tool to create environments, so terrains, road networks, but also an authoring tool to create vehicles, importing CAD models, 3D models, and importing your vehicle dynamics. If you're using another solution, it's possible. Designing your entire vehicle dynamics. And so it's used by a lot of companies in the automotive industry to validate, for instance, GUIs, infotainment systems, but also the entirety of the vehicle. Um, of course, it's widely used for designing ADAS systems. Uh, and really, the big challenge of today when we design ADAS systems is the human factor, because you can train your ADAS system with a machine learning algorithm to detect SOTIF cases, for instance, but um, you will always encounter this human factor that we're going to talk about. So, being, for instance, drowsiness, or the driver maybe being tired and starting to fall asleep at the wheel. This is the kind of human factors, stress factor too. This is the kind of human factors you must encounter when you design ADAS systems. And so Scanner allows you to either simulate these human factors through scripting, or actually put an actual driver in the loop, because it's also a driving simulator. So put an actual driver in the loop and connect them to Scanner, and monitor their behavior or their biometric data. So the goal of this presentation today was to show you a use case that was designed by a company that accredited us to create a proof of concept in a very small time window with a very small budget. That was the goal. It was to create a complex scenario from start to finish, um, with a very limited budget and time constraint. So the objective of this proof of concept was to integrate a voice assistant like Google Home or Alexa or Siri for iPhone, for instance, into the vehicle driving experience and see how the driver reacts. So what we offered, what we proposed for this company, was to help them through the whole process of designing this proof of concept, helping them specify the scenario. So they came forward to us with a wide variety of specifications and use cases they wanted to integrate to the scenario. And so we integrated it directly with Scanner. So we prepared everything on the workstation because Scanner can be run on a workstation for the authoring part. Mostly when you want to do scripting and terrain and road network authoring, you do it on a workstation. But then you can also run it on a driving simulator and connect the two computers, the supervisor and the driving simulator. So we prepared all of this on our simulator in our showroom on location in Paris. So the simulator we're using, by the way, is a Simflex, which is a simulator that you can buy at the end of this presentation if you want. It's a simulator that we sell a lot because it's very versatile. The goal of this simulator most of the time is to be used as a kind of sandbox modular driving simulator experience. So you can easily add and remove peripherals and screens and devices to it, attach it. So we integrated then everything. And then we simulated the whole experience. Right after this, I'm going to show you a video of the simulation. And then we provided them with a wide variety of KPIs. So all of this was done with one single software, Scanner Studio, from the specification all the way to analysis of the simulation recordings. So this was the simulator that we used. As you can see, we added a wide variety of different human factors recording systems. So we used what we call a smart eye, which is an infrared camera that's going to track my eye movement in a very precise manner. And then we added also a sensor on my wrist, which is a very basic heart monitoring watch that you can buy in any outlet store. And then we added this small ring around my finger that was used to test my reaction during the simulation. So we have the simulation running. As you can see, we added a wide variety of different scripts during the running of the simulation. You can see this little dot here symbolizes the autonomous mode being triggered on and off during the simulation. So you can display images very easily on Scanner using this, but you can also display text informations about the simulation running. As you can see on the supervisor computers, so both computers are running the same simulation synchronized, and on the supervisor computer, you can move the camera around freely to see what's happening around my vehicle, but also a very important data, you can monitor it directly at runtime. So I'm using a steering wheel sensor drive, by the way. Oh, sorry. And so the objective of this first part of the scenario was to showcase just manual driving. That was the beginning. First step was using manual driving. So you can see there's a red dot from time to time. This is used to measure the driver's distraction. And so I have to press on it with my index finger on my left hand. And it's going to measure my response time in milliseconds. It's not something that's out of the box in Scanner. It was asked to be developed for us by the client, and we developed it in this very small time window I showed you. In only a few days, everything was working, and we were able to show this this nice package. You can see the eye tracker at the top right of the window. So in real time, you see it tracking very precisely where the driver is looking. We also added an eye tracking feature to the scenario, which is going to stop the car from accelerating and make it emergency braking if it sees that the driver is looking away from the road for more than 3 seconds. So this was also asked by the client, and so we were able to develop this feature. We'll show you all of this. I say we're able to develop, but all of this is actually extremely easy. It's mostly visual scripting, so it's pretty much a turnkey system. The main goal of this experiment, of course, was to interact with the virtual assistant. So right now we developed a script that interacts with the virtual assistant. So right now I'm asking the virtual assistant to play music for me, a playlist. So the goal was to see if the driver was being distracted by this kind of events. So everything that's running, by the way, on the screen right now is being recorded in a GZ file, and then you can see the recording in our analysis tool, it's called. So it's also a package in Scanner. All of this is packaged in one single solution, Scanner. And so you can interact with the recording at the end, and it's all synchronized with the timeline. I'll show you a few screenshots later on. So I just enabled the autonomous mode. We binded it to a key. It's very easy to bind the different events to the keyboard or X inputs or any USB device. Even from UDP packets, you can trigger events. And so for my finger, for instance, we actually use the keyboard controller. We took it from an old keyboard and mapped my finger to one of the keys of the keyboard, and that's how you can create these human factor use cases, proof of concepts with very cheap budgets and very efficiently too. So then we added a feature. So I'm showing right now to you the feature where when I'm not looking at the road, my car is going to stop. So I'm looking at my phone right now, and my car in autonomous mode stops driving. And then when I look back at the road, it starts accelerating again. So you could imagine enabling that and adding this feature to your existing ADAS models. So then for the next 5 minutes, it's just a long stretch of highway. The map the simulation is running on, by the way, is the USA map, which comes as an add-on. If you want to evaluate your simulator in a very realistic US environment type, you can purchase this package. We also offer the Europe 2, it's called Europe 2 map, which is pretty much like the US map, except it's way more focused on Europe infrastructure. We have mountains, and yeah, it's very different. Not the same types of vehicles too. But yeah, our clients chose the US map because they were based in the US. So at 10 minutes, we triggered an event during which a car passes in front of us. And so it brakes very hard in front of the ego car. And so it forces our autonomous driver to overtake it. All of this was done through visual scripting very easily. It only takes maybe 5-minute stops to develop these kinds of events. And while I overtake the car, you can see the smart eye tracking my eye movement on the right screen. Note that I'm not necessarily moving my head, but just the movement of my eyes is enough for the system to track. Then you have a city driving section. So when we approach the city, we ask the driver to go back to manual driving mode. So then the supervisor, you can see that's the supervisor who is triggering this event. And now it's back in manual driving mode. So the goal of this part of the simulation, of this proof of concept, was to see how the driver would interact with the voice assistant while in manual mode in a city environment. So with a lot of cars moving around, you have to drive slowly, uh, give attention to the signals, the markings. And so right now I'm asking the virtual assistant the nearest path to the coffee shop. And so it triggers, you can see on the screen these directional arrows using a visual GPS itinerary. So you can, by the way, use GPS itineraries in Scanner. That's one of the features the numerous features of the software is that you can import GPX data directly into Scanner to create these itineraries. We also support OpenStreetMap, so you can really see how versatile the software can get when you do these kind of studies. With the green arrow on the screen, you can also see that it's very easy to integrate maybe new GUIs or new car interior configurations before, for the validation and designing parts before integrating it to the actual vehicle prototype. So the goal, of course, would be to save a lot of money in the development. So now we added a script that makes this pedestrian cross when I arrive near it. So same thing, the goal is to measure my attention and see how fast I react. It's done using triggers inside Scanner Studio. So right now I'm just showing you the demo of the simulation, but afterwards we'll go step by step through each event and see how it was done in Scanner. Another script we designed was a car pulling out of a parking spot that would trigger the ABS if I wasn't quick enough. And so this was also a custom KPI to measure my reaction time when I hit on the brakes and see how fast I react. So this is just more city driving. By the way, all the vehicles you can see, so I'm just talking about the scripted parts, but all the vehicles you can see driving around me are all controlled by our traffic module. So these are not scripted, they're just AI controlled. So this is how easy it is to create a scenario in Scanner. You just use the map pre-made for you that you purchased, or we also provide a dozen of maps readily available for free when you get the basic Scanner Foundations pack. But if you want a more detailed environment, for instance, for computer vision, let's say, you have these kind of maps that are also available. And so I've reached my destination. And now, using a script, same thing, the simulation ends when I reach this part. So how did we put all of this together? So first of all, we used Scanner on a workstation, and we mapped all of the different events and also I/O from the simulator directly inside Scanner using the acquisition module. The image generation is used using our visual module. So it's running on low resolution in the supervision interface to save on resources. But of course, all of this is modular. If you want to run it in 4K on the free screens, plus the supervisor, you can change all of this in the configuration files very easily. And we enabled border decorations. You can also do that for the visual, so that you can drag it around your screen easily. So this is the 3D environment generation part. We also support Unreal Engine since Scanner 2021. So now you can generate the 3D rendering through Unreal Engine, which gives you a way more photorealistic look to your simulation. The other modules we used were the eye tracker and the physio module. So the physio module is part of the human factors pack. When you purchase it, you have access to the physio module. And what this does is that it helps you connect ANT-enabled peripherals, so ANT, which are physiological biometric tracking devices. So pretty much heart rate. Most of the time it's for monitoring heart rate. And the eye tracker module, which connects directly to the smart eye. So smart eye in this simulation is running on yet another computer. So we have three computers. One is the supervisor. The second one is just the simulator. So with the acquisitions, the sensor drive wheel and the visual, and a third computer which is the supervisor. Sorry, the smart eye system. And so we added some custom WAV files and custom images to show on the simulation. So it's really straightforward. You just design your images in whatever authoring software you want, and just drag and drop them in the right folder, and you can access them from Scanner. So this is a video that shows you how easy it is to get started. So you have a supervisor view of the map, and you can just drag and drop vehicles and start populating your environment. You can also use the swarm module to generate a traffic with a radius around your vehicle. And it's gonna make the vehicles despawn when they reach the outer ring of the radius, and make them respawn behind you or in front of you, so that it saves on performances. So that's just what I showed you. So the ego vehicle is using our homemade vehicle dynamics model, which is called Calais. But you can also, of course, connect your own vehicle dynamics, being CarSim, CarMaker, um, VI-Grade. We support a wide variety of other vehicle dynamics manufacturer. And so the scripting inside Scanner is done in this fashion. You can just drag and drop functions using rules, conditions, and setting interactive variables. All these variables, you can also show them in a little window like this that's going to pop up during the simulation on the supervisor computer, and they can interact with these variables at runtime. The great thing about Scanner is that for all the functions you see on the screen, you get proper documentation explaining to you each parameter, how it's supposed to be used. Sometimes you even get little schematics or drawings to explain to you in which situation you should be using these functions, how your car is going to be interacting with the environment if you use it, if you use this function. So the lead vehicle at the beginning of the simulation was also scripted. So we scripted the text being displayed on the front screen. Once again, very easy to display text in Scanner. Just one function, and that's it, with interactive variables too. And just with these two lines, we made this vehicle go at the same speed as our ego vehicle. So regardless of the speed of my ego vehicle, this one is always going to be at the same distance in front of me until I enable some Boolean logic and make it stop doing it. And so yeah, you can. It showcases how super easy it is to do scripting inside Scanner. Just with these two functions, you're done. And so this was another function that made the lead vehicle brake um, once the triggering event for the Alexa asking me to play the music has been true for more than 3 seconds. So you have this kind of Boolean logic also enabled inside Scanner. It's not only true or false, but you can also add logic like has been true, has been false, um, is not true anymore. You can use this kind of logic. And you have also clocks, very precise clocks down to the millisecond inside Scanner. So this is the pedestrian that was showcased in the video I showed you. Same thing to make the pedestrian cross the road. It's extremely simple. See here, this is a trigger. So this is the view on the supervisor when you're editing the scenario. You get actually these little rectangles of color. So the blue circle around the actor means that it's inactive. So when it's inactive, it means that it's just present and visually here in the simulation, but it won't do anything until it's being triggered by something. So in this case, this is the trigger. I put it right at the stop line. And so once I'm inside this trigger, I can also specify which vehicle is going to trigger this rectangle. So if the traffic passes this trigger, I don't want me to be active. Only when my ego vehicle does it. It's very easy. It's all GUIs. You don't have to program anything. You can just select the vehicle you want uh, to be filtered by the trigger. And so once it becomes true, because I don't want it to repeat this action every time it's true. So at every frame of calculation. So once it becomes true, then I activate my pedestrian and I ask my pedestrian to cross the road. 90 is the angle, the crossing angle. So for this particular help window, you get a nice little diagram showing you the angle of the pedestrian and how they're going to cross the road. And yeah, so just with these 3 lines that are not even typed by hand, it's all visual programming. You can make this pedestrian cross to do, most of the time is to do AB or ABS triggering events, but in this case, it was for human factors. This is the car pull-out event. So much like the pedestrian, there you get 3 different triggers. So a bit more complex, but the idea is the same. Once I reach my trigger, I want the vehicle to pull out of their parking spot. So we have a function called lane lateral shift. Um, and yeah, that's so easy it is to control an actor vehicle. You can also control your ego vehicle, of course, through visual scripting. So what I didn't mention is that you can do visual scripting in Scanner, but we also have a complete SDK in Python. So all the functions you see here are also available in Python, and you can interact with the simulation using your Python scripts. So that was the slow vehicle, if you remember, that was overtaking me and was braking hard in front of me during the highway section. As you can see, you can include visual scripting elements. So let's say you developed a whole script of overtake, which is extremely complex with all the use cases developed and that is abiding by specifications. You can reuse it. You can reuse it in all your simulations by just including it like this, using an include. So you get all the power of a real programming language like C++, for instance, or more like Python or Basic, while also being extremely easy to use even for people who don't have a programming background. So this is the part where we developed the detection response task. So as you can see, most of the scripts is about setting the red dot. As you can see, you also have random functions, get random values with a range. 90 being the percentage of the screen, so it's not an absolute resolution for the screen. So you can change the configuration of your screens. It's not going to break your script. And so yeah, most of the script is just displaying the image, removing the image, and every time you click on the button, so it was positioned right above the wheel, it's gonna trigger an export channel. Um, that's what it's called in Scanner. And so an export channel is a particular channel that you can um, extract from a simulation recording to have custom outputs in the recording. So if the recording is not complete enough and you want extra KPIs, you use what we call export channels. So this is the specifications. And this is what they look like when they're integrated using mice scripting. That was the iGlance module. So as you can see, this is actually C++. We offer a scanner C++ SDK. This is used when you want more precision performance, and when you want to do scripting that is just faster than using mice or Python. So this is a scanner module. So what we offer with the scanner SDK is includes and libraries to interact with scanner. And once it's compiled, it's just a small DLL or exe file that you can add to your simulation as a scanner module. And then you can interact with your module directly using using the visual scripting. So same thing, we used the export channel function to export it in the recording. And so what this port did was it was checking for your screen ID. All of these enumerations that you see, they're all documented too, of course. And so if it's -1, it means that I'm not looking at one of these three screens so away from the road. And so if I'm not looking at one of these three screens for more than 3 seconds, then I stop the car with a very precise brake force applied to the pedal. The auto mode was also developed as a scanner module in C++. So much more like the eye tracking. You can see that you can do a combination of low-level C++ interaction with the simulation and visual scripting. So these are all the KPIs we extracted from the simulation. So this is from the scanner documentation. This is just a part of what you can extract from a recording. You have many more. Fields that you can extract. By the way, when I say extract, it's either on the analysis tool, which looks like this. You can add multiple graphs in one single window, as well as a 3D representation of the simulation, and all of them are synchronized. Or you can extract them directly to an XLS or MATLAB file, or even CSV if you want. So these custom outputs are, for instance, the cognitive tasks. So these are this is the time I took on average every time I clicked on the button on my index finger on my left hand. And that's the brake reaction time from the car pulling out of the parking spot event. And once again, all of this was developed in a matter of days, 3-4 days. So all that I showcased today is inside the human factors pack. So if you already have scanner, if you plan on getting scanner soon, you can purchase the human factors pack, which will allow you to add all the features I just showed you. So being the physio pack, which will enable you to connect the biometric sensors to scanner, but also add eye tracking functionalities to scanner as well. And also stuff like VR, augmented reality, or mixed reality. We support a wide array of different VR headsets that you can connect with our visual rendering. So you can go to our website. You have a descriptive page of everything that we provide with the human factors pack. So why is scanner used by all of these actors in the automotive industry? Most of them like scanner very much because of its interoperability with other existing solutions. Scanner is exposing everything that's running in the simulation through UDP. And so with the Scanner SDK, you can very easily connect Scanner with any of your existing software. Even your CAD software, you can export your 3D, the 3D of your car inside Scanner. If you're running vehicle dynamics specialized software, you can connect it with Scanner. If you're running a specialized software just for your traffic, just for your traffic module, you can connect it with Scanner. That's very much the power of the software. It's also compatible with HPC, of course. So I didn't talk a lot about at all, in fact, about high performance computing and massive simulation today, because, well, you can expect that with the human factor, it's quite difficult, right? But it's a use case that has been used a lot by our clients, running massive simulation for ADAS validation, for instance, in the cloud. Um, and it's all GUIs. You can do everything from start to finish, from A to Z, without writing a single line of code. It's all visual scripting. If you want to go even more low level, we also provide C and C++ and Python SDKs. So we always give the choice to the customer on at which level they want to use the software, from a very basic perspective, to create a proof of concept very quickly, but also very complex in a very short time, but also enable them to do extremely complex use cases. So AVS, we accompany you from start to finish with your project. We can help you with advices. For instance, to create the specifications for a project, we can build the project for you as a service and operate it on our own simulators. And so we can provide you a video like I showed you, or we also provide, of course, the actual simulators if you want to buy them and integrate Scanner in them. We provide a wide array of very different simulators from all shapes and sizes, from the simulator I showed you, the SimFlex, all the way to massive hydraulic 6 or 8 degrees of freedom simulators. We provide startup assistance, so this can be used when you're on either on trial. So if you want to try Scanner, it's free for 30 days. But if you just bought Scanner and you have difficulties using the software, we offer you what we call startup assistance, which is for up to 5 days, one of our engineers goes on location for you and helps you out with the software. But so there's this, and we also provide training. So we have different training packages. It can be done on site, on remotely. So the takeaway for this presentation is that Scanner allows you to design your human factor studies with extremely easily and with cost efficiency. As you can see, what we used wasn't super high pricey hardware. It was all very simple stuff. Your steering wheel, your pedals, you connect it to a screen. If you don't want to do it yourself, you can even buy the simulator pre-made by AVS and just connect it to Scanner, and that's pretty much it. All the scripting, all the difficult parts are abstracted behind layers, and as the end user for you, it's super easy to integrate. We offer services throughout the integration uh, of our product on your ecosystem, and we offer services to help you design your project from start to finish. And Scanner is one great package with all the tools you need, from design of your experiments and your ADAS products, all the way to the validation and analysis of your simulation and your products. So I encourage you to start a Scanner trial for the ones who have never tried Scanner. You can use it for 30 days. During the trial, you will have pre-sales engineers, such as myself, that you can contact anytime you want. So then we can give you assistance and make you understand how Scanner works and give you advices, help. We have a quick starts page too. So this quick starts page, it's a GitHub page that provides you with a ton of demos and samples. Um so you can try out all the features of Scanner. It's really tailored at people who are using the trial for 30 days, so they don't have much time. You can try all the features of Scanner in these very complex scenarios. You can also read the source code to get inspiration, and also watch our web events. We produce at least one web event a month, and also our YouTube channel. We post tutorials, getting started videos, but also how-tos or focus-ons, such as this one. So I greatly advise you to check out all these resources, especially for the ones who are just starting with Scanner. It's a great way to get started. Just a quick note before we start the Q&A section. We are having the Scanner Day, so once a year for a day, we organize something on location, on site. It's an event during which we show you the new features of Scanner Studio for the new version, as well as new products, user presentations, so use cases from key industry players, and workshops, and you'll be able to meet the experts as well as the sales execs, the developers. It's a very great opportunity. Plus, it's in Paris. We organize a dinner cruise on the Seine. So great opportunities during the Mondial de l'Auto, so the automotive exhibition in Paris. So it would be, if you're planning on going to the Mondial de l'Auto, I will also advise you to go to Scanner Day. It's free, so don't hesitate to email us or ask to be registered to the event. Okay, so that is all for me for this presentation. So now we can have a quick Q&A if you want. Do you have any questions?